rock stars of Python. This is Prof G, and it's time to make some noise. We're going to connect a simple speaker with an RCA jack to a microcontroller. I'll show you some sample wiring schemes for an Arduino Nano RP2040 Connect and an Adafruit QT Py RP2040, and that should get you started wiring up just about any board that supports the Audio I/O library. Then we're going to learn how we can play both WAV files and mp3 files. We'll get some tips on setting up audio files for playback in CircuitPython, and we'll have some fun challenges where you can use your skills to hear encouragement from perhaps the galaxy's greatest teacher. So Python Padawans, let's code! In this tutorial, I'm using a speaker with its own power source, and that prevents us from having to mess with additional speaker power, amplifiers, and other things that make the build more complex. And here I'm using what's called a hamburger speaker. It's especially useful because it has a built-in rechargeable battery for portable projects, and it can be charged or powered from a USB cable that comes with it. These are pretty inexpensive and they're sold by lots of vendors. But if you have any speaker that has its own power and this kind of pin-style RCA jack, maybe an external cell phone speaker, or even a pair of plug-in headphones, then you can use those as well. Then all you need to do is clip 2 additional wires to this round RCA jack. Now a ground wire goes to the base or sleeve of the jack, and the digital out wire should go to the tip. And here are some additional wiring diagrams to show you how to connect the speaker wiring to the boards. The tip of the wire on the audio jack can go to any digital pin on your board. So I'm using D3 on the Arduino, and I've got the sound wire to A0 on the QT Py RP2040. Most any other board that supports digital I/O should have a very similar setup. I've also included buttons in these diagrams. I figured we should use a button since we learned about them in the prior video, and in the challenge you'll trigger a sound when a button is pressed. Now for this tutorial I've given you some properly formatted files, and you can find these at the URL bit.ly/circuitpython-school-files, all lowercase. This will bring you to a Google Drive. Just highlight the sound folder, right-click on it, select download, and then once your board is plugged in and it appears on your desktop as CircuitPy, drag the sound folder into your CircuitPy volume. Now, if you want to set up your own sound files, know that CircuitPython expects WAV files saved with the following specs. They need to be mono files, not stereo. Some boards support stereo, but you can explore that on your own if your project really needs stereo. Now, files should be saved as 22 kilohertz and saved as 16-bit files. Now, for a newbie or even an experienced user, those terms might not be familiar, but fear not. If you want to convert an audio file to this format, you can download the free Audacity software. It's available for both Mac and Windows, and here's where you'll find the settings to convert the files to the format I just explained. So if you open Audacity, stereo down to mono is under the tracks menu. You'll use a menu in the lower left-hand corner to convert down to 22 kilohertz. That'll be listed as 22,050. Then the file menu will let you export the file as a WAV file, and the box that pops up should allow you to select the 16-bit format. Now I've also got a more detailed tutorial on how to do this in the CircuitPython School playlist, but this is likely all you need to format your own audio files as CircuitPython-friendly WAV files. Just know that you don't have a lot of storage on most CircuitPython boards. Most boards have 2 megabytes max, and that includes your CircuitPython programs, so you'll want to make sure that your files are small. There are some add-on boards that will let you store larger files, but also if you use CircuitPython on a Raspberry Pi, the Raspberry Pi has a lot of storage. If you ever want to do something with lots of audio files or where you need more audio file space, the Raspberry Pi is a great choice. And you'll find some tutorials on how to do Raspberry Pi audio in CircuitPython on my channel as well. So to work with WAV files, we need to import digital I/O, and we'll import WAV file from Audio Core. And then we need to import audio out. Now note that some boards, like the original Adafruit QT Py, don't have audio out support. QT Py RP2040 does, and some other boards support audio out in different ways, and that might require different imports. So this block of code first looks for audio I/O, and if that's not available, then it'll look for audio PWM I/O. So those are 2 places where audio out could be found. These are built in, so you don't need to worry about putting anything additional in your lib folder on your board, and if your board doesn't support either of these methods, then you'll see this message in your serial console: this board does not support audio out, and you can't continue with this tutorial until you get a board that supports audio out. Now once you have audio out, then you can use it to create an audio out object. I'm calling mine audio, and in this example a tip of my speaker's jack is wired to pin D3. Change this if you have a different wiring setup. Then we'll be using the same play sound function that we introduced in the earlier Circuit Playground tutorials. That function is going to look for a path. So make sure that this variable is set to the name of the folder that holds the sound files, and the slash at the end is necessary. That separates the folder name from the name of the sound file. Now here's the play sound function that we introduced in our Circuit Playground lesson. Again, we see that so much of the wonderful CircuitPython code that we write works on multiple boards, and this program imports raw binary. That's what the RB stands for. Those are the 1s and 0s that make up the data in that file, and that's found at this path or folder for the file name that's passed into this function. Now this data is going to be held in a variable called wave_file. Then we convert that raw binary file, the ones and zeros that we just imported, to a WAV file. Then we play this converted file through the audio object that we set up in the code in the prior screen, and this while audio playing loop will just let the entire file play before it executes the rest of your code. Now, one more thing to note, if you want to do additional things while the sound plays, like animate neopixels or move a servo motor, then you can put code to do that here, replacing the pass statement, or you could write it as a separate function and just call that function here in place of the pass statement. Now, whenever you want to play a sound, just call it like this, play_sound, passing in the string of the name of the file that you want to play, again making sure that you add the file extension .wave in this case. So let's code this up and see if we can get this magical wand sound playing from our board. So over in Mu, we're going to code up a file to play wave files from a microcontroller. We're going to import time, board, digital IO, and from audio core, we're going to import wave file. That's capital W, capital F. And then in this block of code, this code tries to import audio out from various locations because not all boards have audio out in the same place. And the except code runs if an import error is generated by the statement after try. If both import errors are returned, then we print the error message. So we're going to say try, from audio IO import capital A audio capital O out. Then outdent except is paired with the try above. They should be indented at the same level. Except, and then capital I import capital E error one word : So what happens here is we try to import audio out from audio IO. Now if this works, we're going to skip the except statement and everything that's indented under that statement. But if it doesn't work and it generates an import error, then we're going to try something else. So try, from audio PWM-IO, import capital P, capital W, capital M, capital audio, capital out, as capital audio, capital out. So first we try to import audio out from audio IO. Next we try to import PWM audio out from audio PWM IO, and we'll name that as audio out. Now if this works, then we're going to skip the except statement that we're about to write below and everything indented underneath that except statement. But if it does not work, then we generate an import error, and we'll deal with that error by printing out a message. So we outdent and say except import error, capital I, capital E, and then we've exhausted our possibilities, so on the next line we're just going to print, and in parentheses, quotes, this board does not support audio out, and then we'll put a pass statement after that. And actually, I don't need the pass statement here, so you could get rid of that. And again, the reason we have this block of code is that not all boards can play audio with audio out. And I'll press return a few times just to make it easier to see what I'm typing. And now let's create an audio out object and set a path where our sounds can be found, and we'll do that by saying audio equals audio out, capital A, capital O, and in parentheses, I'm going to say board.D3, because I have the pin that's clipped to the tip of my speaker plugged into pin D3. And I'm using the Arduino Nano RP2040 Connect here. So if you're plugged into a different pin, make sure that you add that pin's name here. Then I'll add the path variable, which contains the folder where our sound files are stored, and that's going to be path equals, and in double quotes, sounds / Now, two things to remember. One, you can name the folder that holds your sound anything, but this string needs to be spelled exactly the same as your folder name. I've seen students waste a lot of time on errors because they forgot, for example, to add an S at the end of a folder name, or they got the wrong capitalization. And the second thing to remember is to make sure that you add the / at the end. The / is a separator between your folder name and the file name, which we pass into the function when we call it. Now, if you ever get an error like this, no such file or directory, that means the file couldn't be found, so either the folder isn't spelled properly in the path, or you're missing your /, or the sound file in your folder is spelled differently from the file name you're using in your code, or your folder simply doesn't have the sound file you're trying to play. So if you ever get this error, these are the things you need to check. Then let's define our playSound function, and this is the same playSound function that we used in our previous Circuit Playground exercises if you did those. We'll say def space play_sound in parentheses file name, that's the string that we're passing in. Make sure you got a colon at the end, and then on the next line with open and in parentheses path plus file name, comma, in quotes RB as wave_file : So what this is going to do is it's going to try to open the file name at the path and read in the binary ones or zeros that make up that file, and it's going to store it in a variable wave_file. Then the next line will say wave equals wave file, capital W, capital F, and in parentheses we pass in wave_file, the ones and zeros that we got when we opened the path above. Now what we do here is we turn those ones and zeros into a valid wave file, and then down below we can say audio, which is the audio out object we created above, .play passing in wave. That'll start playing the sound, and then underneath we'll say while audio.playing : button, and I'm going to put a pass in here, but this is where you can add any code that you want to run while your sound is playing. So if you have LED animation code, put it in here. If you're moving a servo when a sound is playing, put that in here as well. You can also put that code in a separate function and just call the function here instead of the line that says pass. And the code we've written above is very reusable, so anytime you want to play a WAV file, you can just copy and paste this code and you're good to go. Then, rather than using a while true loop, we'll just play the sound once and then our program will end. So we do that with the statement play_sound. That's going to call our play sound function that we just wrote. And in parentheses, we'll pass in double quotes the name of the file. That's the full name, wand.wav, spelled exactly as it is in our folder. Then I'll delete my extra return characters and I'll save this file to my CircuitPy volume, naming it code.py. We open the serial monitor, and we hear the lovely and magical wand sound. Every time we click on save, we run the code again, and we hear that sound again. Nice work! Now, just to show you that this code works on different boards with different pinouts, I've set this up on a QT Py RP2040. Here, the audio out wire is clipped to the tip of the speaker, and that's attached to pin A0 on this board. So I changed my code where I create my audio out object so that it points to board.A0 instead of D3, which I used on the other board. But that's all I need to do. So I can open the serial monitor to make sure that I don't have any errors. When I save my code, press save, and I hear the mellifluous and magical wand sound. There it is again. Nice work. Time for a challenge. So you want to add a button to your board and then play the file encouragement1.wave when the button is pressed. And you'll hear a very special message. So why don't you give this a try, pause, this should be pretty easy, and resume, and let's compare answers. So first I'm going to wire up my Arduino Nano RP2040, and here's the wiring scheme I'm going to be using. Audio to D3, button to D2. If you want to use a QT Py, audio to A0, button to A1 will work great. Just make sure that you change those locations in the code I'm about to show you. And this should work with most other CircuitPython boards too. Just make sure that you're using digital pins for both audio and for your button press. And with the board wired up, let's code. So I'm working with the Arduino here. And this is to play WAV files on a microcontroller on button press. So first we'll name our button equals digital IO dot digital in out capital D capital I capital O, and in parentheses we pass in board.D2 because I've got my analog in pin from the button headed into pin D2 on my Arduino. Then I'm going to say button.switch_to_input, and I'm going to pass in, because we need to create a pull up resistor because the other pin is wired to ground, lowercase pull equals lowercase digital IO dot capital P pull dot in all caps up UP. Then all we need to do down here is to create a while true loop with a colon, and then inside of that loop I'm going to check to see if button.value equals false colon. Remember, we're detecting a button push when we detect false. Then I'll just indent our old play sound call so that it's underneath the if statement, and I'm going to pass in encouragement1.wave. Let's open the serial monitor to make sure we have no errors. Save. I'm going to head over here and press my button and see my secret message.
Code or code not. There is no try.
And ho-ho! It's everyone's favorite 900-year-old green sage. Master Yoda encourages you to code one more time.
Code or code not. There is no try.
So there he is. He's saying code or code not. There is no try. Nice work. You are Yoda-approved programmer. So now that you are a Jedi of playing WAV files, let's see if you can master MP3 playing as well. Now, just before you work with MP3s, Adafruit points out here that MP3 playback is supported on most boards, but not all of them. So if you need to check to see if your board is going to be able to support playing back MP3, you can go to the download page at circuitpython.org and look for audio MP3 in the list of built-in modules available. The boards I'm demonstrating use the RP2040 chip, and those both support MP3, so we're good. And another quick note, so why do we even have these two file types? Well, they are different. WAV files are an uncompressed file format, so these files are larger and they take up more space, but they're referred to as lossless files, meaning that there is no quality loss when we create a WAV file. Now, MP3 files are compressed. These files are smaller, but the compression can cause quality loss. So we refer to MP3 as a lossy file encoder. You can set some parameters when converting a file to MP3 so that you minimize the quality loss, but if you need a higher quality file or MP3s simply aren't performing for you, consider WAVs. Now, it used to be that we only had access to WAV files, but the patent for the MP3 codec has recently expired, so now anyone can create MP3 files without having to pay royalties. So here's how we work with MP3 files. Now, just like WAV files, you may have to resave your MP3 files with a set of parameters to optimize them for playback in CircuitPython. So you can play back stereo if you need to, but if you don't, I found that mono works better. Your file should be saved between 16 and 44 kilohertz. and between 32 kilobits and 128 kilobits per second. Again, those terms might not mean anything to you, but the free Audacity program has settings for all of this. So stereo to mono can be found in the tracks menu under mix. You can set your kilohertz range in the lower left-hand corner, and the file menu will let you export as an MP3. In the save dialog box that pops up, you can select variable and then set the quality range to between 32 and 128 kbps. Now back to our code. Instead of importing WAV file from Audio Core, we instead import MP3 decoder from Audio MP3. Now we still need to set up audio out, so this code will remain the same, and you also need an audio out object, and you need a path too. But this next slide is different. Now first we need to create what's called an MP3 decoder object. So it's going to take the ones and zeros that we read from our MP3 file, and it's going to decode this into something that we can play through our speaker. Now it actually takes quite a bit of memory to create an MP3 decoder object, so instead of creating it every time we call a function to play an MP3 sound, we're just going to create this once before our play_mp3 function, and then whenever we need to play a new file, we're just going to go to the decoder that we created and update its file property by opening the file we want to play. Then we just call audio.play. Now before we can create an MP3 decoder, we actually need to read in an MP3 file. So that's why we have these two statements here. You can set file name to any file that's inside of your sounds folder, and if you didn't want to use 2 lines, you could just put the string directly into file name. We're not actually going to play this file at the start of our program, but we need it to create the MP3 decoder object, which is what we do in this line here. Now, instead of a play_sound function, we're going to call this play_mp3. So again, here's where we simply open the file we want to play. So we take the file name, and then we add this file that we open up to the property of our decoder object. Then we audio play, and what we pass in here is the decoder object. And then we have our while audio.playing pass. Remember, you can swap out pass for any code you want to run while the sound is playing. And then to play a file, you simply call play_mp3, passing in a string with the exact name of the file that you want to play. Make sure you get the extension right, .mp3. It's really easy to forget if you were working with waves to change this to .mp3. And so that's how you work with MP3s. Now we can jump right to a challenge. The challenge is to get code advice by using an MP3 file. So just play the MP3 file encouragement2.mp3 when the button is pressed. So pause, give it a shot, and let's compare answers. So first I'm going to double click on the tab, and I'm going to head into my CircuitPython folder, and I'm going to save this file as play_wave_on_button_press. So now I've got a copy of my wave file code in reserve so I can reuse it whenever I want to. Then I'm going to close this tab and head back into CircuitPython and open my old code.py file. This is what I'm going to change, and I'm going to delete this line from import wave file because I'm not working with wave files, and what I want to import here is from audio mp3, import mp3 decoder. Make sure you get the capitalization correct on that. Then just before our function, remember we need to create the mp3 decoder, and we need to do that by first reading in a file. So I'm going to set file name equal to, and in double quotes, encouragement2.mp3. I'm sure I've got that file on my device. Then I'll say mp3_file equals open in parentheses path plus file name comma and in quotes RB. And then underneath that, I'll create my decoder, calling it decoder equals mp3 decoder. Make sure you get the capitalization right. And in between parentheses, I'm going to pass in mp3_file. That's the file that I read in just above this. And now we're going to rewrite this function down here. So I'm not going to call it play sound. I'm going to call it play_mp3. We're still going to pass in a file name. That'll be the string of the file name that we want to play, and it's got to match a file that's inside of our sound folder. Now I'm going to delete these first 2 lines here, and I'm going to outdent the lines that are underneath that. And audio.play is not going to play wave anymore. It's going to play decoder, so I'll replace that with decoder. And I just need to set the decoder's file on the line above this, so I'm going to say decoder.file equals, and it's the same as the line we used previously, open and in parentheses path plus file name comma in quotes RB, close parens. Then I just need to head down below the if statement in our while true, and instead of calling play sound, I'm going to call play_mp3, and I'm going to play the file encouragement2.mp3. Let's open the serial console, we'll click on save, and head over to our breadboard and press the button.
A code monster you have become. Skilled you are.
And ho-ho! More encouragement for you, Code Monster. Let's hear that one more time.
A code monster you have become. Skilled you are.
Yoda approves of your ability to play both WAV files and MP3 files. This was such magnificent code, I'm going to make sure that I save this to our CircuitPython file as play mp3 file on button press so that I can refer to this whenever I need to. I'll close this up, open up code.py back in my CircuitPy volume. Now just in case you're working with another board, I'll do a quick demo with the QT Py RP2040. Audio in here is going to A0, button digital in is going into A1. So I'll make sure that I change both of those pins in my code, then I'll open my serial console, save, press the button.
A code monster you have become. Skilled you are.
Oh, and you are indeed a code monster and increasingly an engineering monster as well. And once again, we've had big learning. We learned to wire any independently powered RCA jack speaker to a microcontroller. We demoed this on an Arduino RP2040 and a QT Py RP2040. We learned to format WAV and MP3 files using free Audacity software. We wrote reusable functions to play WAV and MP3 files in CircuitPython. We learned how the try-except statements work for error handling. We completed a couple of button challenges, and we learned about the differences between WAV and MP3 files. You deserve to get a little loud when demonstrating your skills because, as Yoda says, you are a code monster. Good work and keep at it.